Before Antoine Lavoisier, chemistry was a land of pure chaos. A murky world ruled by alchemy, mystical theories, and substances that couldn't be measured. Imagine trying to build a skyscraper without a ruler. That was the state of chemistry. Then came Lavoisier, the man who brought logic, precision, and the humble scale to this wild frontier, earning him the title, the father of modern chemistry. Born in Paris in 1743 to a wealthy, aristocratic family, Lavoisier was pushed towards a respectable career in law. But his heart wasn't in the courtroom, it was in the cosmos. He devoured everything he could on astronomy, geology, and, most importantly, chemistry. What set him apart was his obsession with one simple tool, the balance. While his peers were content with vague descriptions and guesswork, Lavoisier believed that true understanding could only be found through rigorous, quantitative measurement. He was convinced that the universe's secrets weren't hidden in ancient texts, but in precise numbers. This meticulous approach, this unwavering faith in the balance, was about to bring the entire, centuries-old foundation of chemical belief crashing down. His journey began in Paris, but it would take him to the very heart of how matter itself works. At the time, the biggest question in chemistry was, what is fire? The accepted answer was the phlogiston theory. It proposed that everything flammable contained a mysterious, fire-like essence called phlogiston. When something burned, it was simply releasing its phlogiston into the air. A piece of wood burned and turned to ash because it lost its phlogiston. It seemed to make sense, but to Lavoisier, it was sloppy, unscientific, and, worst of all, unmeasurable. So, he got to work. He began a series of incredibly careful experiments, all centered around one idea: burning things in sealed glass containers. He would take a piece of metal, like tin or lead, place it in a jar, seal it tight, and weigh the entire setup with painstaking precision. Then, he would heat the jar until the metal inside changed, forming a powdery substance on its surface. After letting it cool, he would weigh it again. The phlogiston theory predicted that the setup should weigh the same or less as the metal released its phlogiston. But Lavoisier found the exact opposite. The total weight never changed. Even more startling, when he broke the seal, air rushed asterisk and asterisk, and asterisk then asterisk. The solid material inside weighed asterisk more asterisk than the original metal. This was revolutionary. Burning wasn't about losing something. It was about gaining something. The metal was combining with a part of the air. Through more brilliant experiments, he isolated this gas. He discovered that about 20% of the air was this active component, which he named oxygen, from the Greek words meaning acid former. He proved that combustion wasn't the release of a mythical substance, but a simple chemical combination with oxygen. With this clear, quantifiable truth, Lavoisier single-handedly destroyed the centuries-old phlogiston theory. It wasn't just a new idea. It was a new way of thinking. The age of modern chemistry had officially begun. Lavoisier's obsession with the balance led him to his most profound and enduring contribution, the law of conservation of mass. Through countless reactions, burning, rusting, mixing, he demonstrated a simple, unshakable truth. In any chemical change that occurs in a closed system, the total mass of the substances you start with, the reactances, always exactly equal to the total mass of the substances you end up with, the products. Matter is never created or destroyed. It just changes form. This seems obvious to us today, but in the 18th century, it was a seismic revelation. It gave chemistry its ultimate bedrock principle, transforming it from a collection of what-if recipes into a hard, quantitative science. But Lavoisier wasn't just a brilliant experimenter. He was a master communicator. And he had a secret weapon: his wife, Marie-Anne. She was a phenomenal scientist in her own right, translating English scientific papers for him, running experiments alongside him, and, most critically, creating meticulous, detailed illustrations of his laboratory setups. Together, they were a scientific power couple. They co-authored the first truly modern chemistry textbook, the Elementary Treatise of Chemistry. This book wasn't just a list of discoveries. It introduced a rational, systematic naming system and nomenclature for chemicals, sweeping away the confusing alchemical jargon of oil of vitriol and butter of arsenic. He gave us our modern definitions: for an element a pure substance that cannot be broken down further, and a compound, he brought order to the chaos. But Lavoisier's story doesn't have a happy ending. Beyond the laboratory, he was a prominent public figure, a wealthy aristocrat. He was also a powerful administrator in the Firme Générale, a private corporation that held the hated contract for collecting taxes for the French monarchy. This position made him rich and funded his expensive scientific work. But it also painted a giant target on his back when the French Revolution exploded. He wasn't a villain. He used his influence to advocate for social reforms, like creating a more logical decimal-based system for currency and whets the very foundation of the metric system. But during the brutal reign of terror, such nuances were lost. His association with the old corrupt tax system sealed his fate. In 1794, he was arrested. The scientific community pleaded for his life, highlighting his immense contributions to France and the world. But the Revolutionary Tribunal was unmoved. One judge infamously declared, "The Republic has no need of scientists." On May 8, 1794, Antoine Lavoisier, the man who had weighed the world, was executed by the guillotine. His friend, the great mathematician Joseph Louis Lagrange, summed up the tragedy perfectly. It took them only an instant to cut off that head, and 100 years may not suffice to produce another like it. Lavoisier's life was cut short by political fury, but his legacy, the law of conservation of mass, the discovery of oxygen's role, and the very language of chemistry, was indestructible. He proved that even in a world of chaos, the truth can always be found in the balance. So what do you think was Lavoisier's single most important achievement? His discovery of oxygen's role in combustion, or establishing the fundamental law of conservation of mass? Let me know your thoughts down in the comments. If you found this story of a brilliant mind cut short as fascinating as I do, please hit that like button, and subscribe for more deep dives into the figures who truly unlocked the secrets of our world. Thanks for watching.